It is 11:10 a.m. on the 6th of November. The lab temperature is 62 degrees, and this is a test and demonstration to see if the TRM sensors SensorCom combo probe can detect West Virginia brine. The brine has been received yesterday. It's dark and has a fairly strong odor of hydrogen sulfide. The fume extraction system in the background is basically just there to keep the concentration of hydrogen sulfide fumes down. There's a PVC fitting, a T-fitting, that is typical of the type used in the under-tank leak detection system, and the probe itself is positioned vertically into the PVC fitting so that any fluid leaking out from underneath the tank would enter the T, fill up the cavity of the T that's capped off at the bottom, and then eventually leak out the side fitting that you see there. So the indication instrument for this particular test is the flasher unit. You can see it in the upper right hand corner of the video, and it should start flashing red if and when the brine is detected. So I'm going to slowly add the brine and we'll see what happens. Okay, that as you can see, we had almost immediate detection. We probably put in no more than about 30 or 40 milliliters, and the depth appears to be just about the bottom 2 centimeters or 3 centimeters of the probe. So we're going to stop the test here, put this foul-smelling brine back in its container, and then we'll proceed to do the test again with naphtha, and then lastly with water. Okay, it's now 11:18, November 6, 2015. The lab temperature is 62 degrees. And this is part 2 of a test of the TRM sensors SensorCom combination probe. As you can see, the flasher is still flashing. I've left it in the latched state after we did the brine detection test. This is fairly typical. The probe itself is probably reset at this stage, but the flashing indicator is designed to latch once it's detected the leak until you intervene. So I'm going to reach over and see if we can reset the sensor. If we can, then we'll proceed to the naphtha test. Using naphtha instead of crude oil. Naphtha is, of course, a little bit more convenient and available than is crude oil, but earlier tests have indicated that the sensor does very well in not only naphtha, but gasoline, jet fuel, diesel fuel, and crude oil. So first, let's see if we can reset the flasher. And we can. That indicates that the sensor probe has essentially, well, it's out of the brine, so there's no conductive pathway to be detected. So now we'll put it into the naphtha, and this should take a little bit longer to respond, but as you can see, it's still pretty quick. And the reason it takes a little longer is a completely different detection mechanism for the hydrocarbon fluids. Now I'll let this begin to evaporate. This takes quite a bit longer than does the brine in terms of reset, but it still should reset in about 15 to 20 minutes. I'm going to set it here on the drip pan, and if I try to reset at this point, nothing happens because the probe is still in the alarm state. It literally will take 15 or 20 minutes for the naphtha to evaporate and let us reset the probe. So we're going to stop again here and come back for phase 3, which will be the tap water rejection test. Okay, we're back for phase 3 of the test. It's now 11:27. It took about 10 minutes, I guess, for the naphtha to evaporate and the system to reset. Again, the latch was set, the flasher was flashing, and then periodically you push the test and reset button to make sure that or to see if the sensor had reset. When the sensor is not an alarm, the reset button down here also acts as a test button. If I hold it, that indicates that the sensor and the wiring is intact and ready to go. When I let go and it's dark, that means everything is fine. It'll also check to make sure that the battery is fully charged to get that good flash. So now we have the sensor back in the PVC T-fitting capped off at the bottom, and we're going to be adding water. This is now tap water from the Redwood City supply. This is fairly high quality urban drinking water. It's coming from the San Francisco Hetch Hetchy system, which usually tests very pure. And it would have a little bit of trace chlorine and fluorine and other, filtering and treatment additives, but at very low concentrations. So this is by no means deionized water. It's our proxy for rainwater or condensation. And okay, we paused the video a bit there since it's not too exciting to watch nothing happen, but we're getting very close to the point where water is going to start to come out of the side of the tea. So we'll finish the test, and water is just beginning to pour out of the side of the tea. So as we add more water, it's not going to get any higher in the fitting because it's coming out the sides. So that's the conclusion of phase 3, and what we've demonstrated is the ability to detect the West Virginia brine, also naphtha as a proxy for crude oil, and the fact that the sensor rejects tap water in this case, like it would rainwater or condensation.